Hey guys, let's go ahead and get started with the notes that we need for Thursday, January 19th. Your agenda is item number 12, and you should be writing the title 4.5 Solving Polynomial Equations Day 1. Our independent practice, that's what you're going to turn in tomorrow before the beginning of class, is problems number 2, 4, and 6. Notebook checks will be next week on Monday and Tuesday because those will be our review days. All right, let's go ahead and get started. Our success criteria that I'm going to focus on today is that I can explain how, I can solve polynomial equations. Here's where we're focusing on today. Tomorrow will be day 2 of this topic, and we'll be looking at how solutions are the x-intercepts. We're not going to get to the graphing part though until after we finish this test. So even though I have that success criteria highlighted, it does actually not fully show to us until we get to graphing. All right, so let's go ahead and get started. This is the worksheet that you have in front of you. The notes that are already typed out in black here are the ones that you have written down. The ones in red are some extra information that I've added that you can go ahead and add to your notes if you prefer. All right, so our steps where we are solving polynomials by factoring, when I'm talking about solving, that means I'm going to get x equals. So I'm going to be looking for what is x equal as my final solution. So step 1, write in standard form. When we write it in standard form, that means we are setting the polynomial equal to 0. Step 2, this is where we are going to factor it. When we start with factoring, we always start by looking for a GCF. Once we have the GCF factored out, then we ask ourselves, can I factor this further? Am I looking for any special case formulas? Am I using the big X? Am I using factoring by grouping? Am I using the quadratic formula? Between today and tomorrow, we will cover all 4 of these, including GCF. I guess that makes it 5. Step 3, we are going to solve using the zero product property. That is where we are going to set each term equal to 0 and solve for X. So a couple of hints that I have here. The first one is the degree of the polynomial lets us know how many solutions we're going to have at the end. And then hint number 2, we want to keep the leading coefficient positive. If we make it negative, we'll have one extra step and we'll have to change the sign. So it's just easier in the beginning to keep the leading coefficient positive. All right, so let's go ahead and get started on problem number 1. We are going to solve by factoring. So first thing I have to do is set the polynomial in standard form and set it equal to 0. So this 24x squared is going to move to the left side of the equation, or it's going to move to the opposite side of the equal sign. So I am going to have 2x to the 4th minus 24x squared plus 54 equals 0. Now that it is in standard form, I'm just going to make sure that I know what the highest degree is. Well, our degree is 4. So what that means is at the very end, I am going to have 4 solutions to this equation. Okay, so to give you an idea what that means, the very bottom down here where it says solutions where x equals, I am going to have to write x equals 4 times. There will be 4 solutions to this equation. All right. Okay, so let's go back here. All right, now, first thing when I'm factoring, step 2, is to look for a GCF. Is there anything I can divide out of all 3 terms? Well, they don't all 3 have x, so I can't factor out an x, but they can all be divided by 2. So 2 goes out front, and I have x fourth minus 12x squared plus 54. Now, even though it's equal to 0, I'm not going to write equals 0 every time. I'll just do that at the very first step and the very last step. Okay, so now here, I want to look at this value, it's our GCF. If the GCF has an x with it, then it is important to us. We are going to have to set it equal to 0. If it does not have an x with it, then it is not important to us. We are not going to have to set it equal to 0, so it's irrelevant at this point. So again, if the GCF has an x, we need to keep it. If the GCF does not have an x, it's not important to us. All right, so let's go ahead now and ask ourselves, can we factor this further? Yes, it's a trinomial. So since it's a trinomial, I need to go ahead and factor that by using the big X. Now, when you're using the big X, remember on top, we put the value that would multiply to A times C, and on the bottom, those same values should add up to B. Okay, so on top of here, you know what? I just realized I made a mistake. This here should not be 54 because when I divide it by 2, it should actually come out to 27. Okay, so I'm going to go ahead and change that to 27. If you can correct that on your end as well, please. All right, so on the top of the big X, we would put 27. On the bottom of the big X, we would put negative 12. So what two numbers would multiply to 27 and add to negative 12? Those are negative 3 and negative 9. These two here are going to be our factors. Now, because the A value is 1, we can use our shortcut with factoring, which means we're going to have two binomials. Take x to the fourth and break it up so that it's x squared and x squared. Okay. Now negative 3, so negative 3x and negative 9x become these factors. Now, someone will ask me, oh, you know what? We're using the shortcut, so we don't need to do that. Sorry, guys. I'm sorry. It has really been very tiring. Let's go ahead and fix that. This one here will be x squared. That part is correct. This one will still be x squared. Okay. And then we will have negative 3 for that one and negative 9 for this one. Okay. No x on them. If I was doing factoring by grouping, then I would need to put the x with them. But there's no grouping because a is 1. All right, now I'm going to look at this first polynomial. This first polynomial here, since it is not a difference of perfect squares, I can't factor that any further. So that one's going to stay left alone. X squared minus 9. This one is a difference of perfect squares, so that one I can factor further. So I'm going to keep x squared minus 3 for the first one. X squared minus 9 can be factored into x minus 3 and x plus 3. That is our special case formulas. That's from last Thursday. Okay, last step, we are going to solve using the zero product property, which means I'm going to take each of these terms and I'm going to set them equal to 0. This is what I was talking about. Every time they're really equal to 0, I just don't write it every time. Okay, so then I have x squared minus 3 equals 0. I would have x minus 3 equals 0. And I would have x plus 3 equals 0. So this first one gives me x squared equals 3. To get rid of a square, we take the square root. So then I have x equals plus or minus the square root of 3. That's my first two solutions. Here I would have x equals positive 3. That's my second solution. And on this one here, I would get x equals negative 3. Sorry, that was my third solution. This is my fourth solution. So on the bottom, right down here where the solutions are, our first solution is x equals positive radical 3. Second one is x equals negative radical 3. Then we have x equals 3 and x equals negative 3. So what does that mean? That means that it crosses our graph at radical 3 comma 0 at negative radical 3 comma 0, at 3 comma 0, and negative 3 comma 0. 4 solutions to our polynomial. Okay? All right, that problem was a little long, so if you wanted to stop the video to work on that, or if you just want to go through the entire video and then come back and do these 4 problems, this video is still here for you to go back to and look at if you don't remember how we got from one step to the other. All right, I'm going to go ahead and go on to example number 3. Okay. Example number 3 here. On this one here, first thing we're going to do is we're going to get it set equal to 0. Okay? So I'm going to move this positive 8 to the opposite side, and it's going to become a negative 8. Now, it doesn't combine with the 4x, it's just where the arrow went. So we have x cubed minus 2x squared plus 4x minus 8, because they are not like terms, equals 0. Okay. Now, when I have this, this is 4 terms. Because it's 4 terms, the only method I can use if I'm not using synthetic division, which we can't, because we don't know x yet. I shouldn't say we can't, but we don't know x yet. So on this one, we are going to use factoring by grouping. Group the first 2, group the last 2, and remember they are still being added together. The first 2 in the first binomial, what do they have in common? Well, they have x squared in common. So we factor out x squared, and then we are left with x minus 2. In the second group, what do they have in common? Well, they have a positive 4. And we're still left with x minus 2. Okay. This is where the outsides become our first polynomial, our first binomial. So we have x squared plus 4. And then the insides become our second binomial. So we have x minus 2. We have to remember they have to match. Okay. Looking at these 2 here, can we factor x squared plus 4? Well, even though 4 is a perfect square and x squared is a perfect square, we only use that shortcut if it is the difference of squares. This is the sum of squares. So we can't factor that further. And then we have x minus 2. That can't be factored. So then we say, okay, let's go ahead and use the zero product property. On this one here, it's a degree of 3. That means we are going to have 3 solutions. Okay? So using the zero product property, I have x squared plus 4 equals 0, and I have x minus 2 equals 0. Okay, so on this first one, I have x squared equals negative 4. Take the square root of both sides, so I have x squared is equal to plus or minus radical negative 4. Now, we cannot have a negative under the radical. Back up. This is x. So I took the square root, so I have x equals plus or minus the square root of negative 4. Okay, so when you take the square root of a negative number, we can't do that. So that's when it becomes imaginary. This is when it becomes complex. So x equals plus or minus I radical 4. That there is 2 of my 3 solutions. This one here, this is easy. This is x equals 2. There's my third solution. Can't they all be that easy, right? So when we are writing out our 3 solutions, oops, I think I actually moved that to the other page. Our 3 solutions are going to be x equals I radical 4, x equals negative I radical 4, that's the plus or minus, and x equals 2. If they wanted us to write them as ordered pairs, I'd have I radical 4, comma 0, negative I radical 4, comma 0, and then 2, comma 0. Okay? All right. So let's go ahead and, excuse me. Let's go ahead and work on number 5. Yep, here's my solutions. That's where I must have moved it to the second page when I didn't need to. All right, last one we are going to do together is number 5. So on this one here, again, set it equal to 0. So move the 12x squared to this side. So then I will have 2x cubed minus 12x squared plus 18x all equals 0. Now on this one, again, look for the GCF. What do they have in common? Okay, looking at it, can you tell me how many solutions you think it's going to have? Get that number down, and we'll see at the end. All right, so what is the GCF? Well, this time, if you notice, they can all be divided by 2. Also, they all have an x as part of their factors. So we are going to factor out 2x. So then I will be left over with x squared minus 6x plus 9. All of this equals 0. Okay, now looking at our GCF, if the GCF has an x with it, then we need to keep it there. If it doesn't have an x, we can cross it out. It's irrelevant. Well, this time it does have an x, so it is relevant. We have to keep the 2x. I can't let go of it this time. So it has to hang out this whole time that we're factoring. So we have 2x. This is a trinomial. Fortunately, a is 1 again, so that makes it a little easy. But when it's a trinomial, let's go ahead and use the big X. So the number that goes on top is 9. The number that goes on bottom is negative 6. Two numbers that multiply to 9 that add to negative 6 would be negative 3 and negative 3. These are my factors. All right, so when I'm factoring that trinomial, I'm going to have 2 binomials. If I take the x squared and I split it up, that gives me x times x. Then I have negative 3 and negative 3. So x minus 3, x minus 3. Now that it's all factored out, no other factoring that I can do. I show that it was set equal to 0. Remember, it really is set equal to 0 all along. I just don't write it. Then I have 2x is equal to 0. X minus 3 is equal to 0. And x minus 3 is equal to 0. So here, divide both sides by 2. 0 divided by 2 is 0. There's my first solution. X minus 3 equals 0, so that gives me x equals 3. There's my second solution. Then here I have x minus 3 equals 0, gives me x equals 3. That is my third solution. And our degree was 3, which tells me we're going to have 3 solutions. Okay. Now, these two solutions here are the same. So what that means is that when we have a graph where x is 3, this graph would actually hit it here and bounce right back up, right where x equals 3. Okay? And again, we'll get to that stuff when we get to graphing after this next test. All right, so then our solutions, we have x equals 0 or 0, 0. We have x equals 3 or 3, 0. And we have x equals 3, which is 3, 0. Now, if it was big ideas, you would only write it twice. You would do x equals 0 and x equals 3 because they see that both of them happen at the same place. Okay. All right, that is it. You've got 3 problems to work on, problems number 2, 4, and 6, and make sure that you upload this to Canvas. Sorry about my mistakes, guys. It has really just been a long time, lots going on.